So again, I'll do this two different ways. So you can't be, remember, content with not knowing how to do something. The first thing I'm going to do here is factor it by guess and check. Our target sum is -1. I told y'all that when your target sum is small, you want to choose factors of the first and last that are close to each other. Because when things are close and you have to subtract, you know that you're going to get a small number, right? By the way, you're going to have to subtract to get your target sum because the last one, the constant is negative. When the constant is negative, we get it by doing, the last in each binomial, and a positive times a negative is negative. So when you have a positive and negative, when you add them, you're really subtracting. So I know I'm going to have to subtract. So here's what I'm going to do. As always, I'm going to get my factoring receptacles in place. There's no common factor. That's what you would look for first. The leading coefficient is not negative, so we don't need to factor that out. Factors of 12 that are close to each other. 3 and 4. So a 3x and a 4x. And I don't even know if this is going to work, but I'm trying it. Factors of 6 that are close to each other. 3 and 2. Now watch. If you try a 3 and a 2, let's see if it works. That gives us a 12x on the inside and a 6 on the outside. What's 12 minus 6? Is it 1? No. And if you want to do the other, what's 12 plus 6? That's 18. That takes you farther away. So maybe it's not a 3-2 combo. You only have to switch one of them. You don't have to switch the 3x, 4x. You can lock that in place. But maybe instead of 3-2, maybe it's 2-3. Let's try that. This gives us an 8 here, and this gives us a 3 times 3 is 9. What's 9 minus 8? 1. Or what's 8 minus 9? -1. That's what we want. So now, because we do have a negative sum, we want the larger number, which is the 9, to be negative. So in order for the 9 to be negative, the negative has to go in front of the 3, and a positive has to go in front of the 2. Okay, so that's one way to factor it. Guess and check. You could FOIL it back out and make sure it works. All right. The other way to do it is more of target sum, target product. You look at the first and last. That's your target product. Okay. 12 times -6 is -72, and your target sum is -1. So now you're looking for factors of -72 only that subtract to give you 1. What are some factors of 72? 8 and 9. Yeah, very good. So this is going to be the same as -9 times 8, and -1 is going to be -9 plus 8, or 8 and -9. So what we do is we split the middle term, 12x squared minus 6, and then we take the -1x and we write it as -9x plus 8x. Splitting the middle term. What that allows you to do, remember, is you're looking at one number only, 72, instead of combinations of 2 numbers. Now what we do is we factor by grouping. I can group these together, and because this is a plus sign, not a negative sign, I can put the parentheses between the plus sign and the 8. If that were a negative sign, I'd have to put the parentheses outside the negative and squeeze my own plus sign in between them. Because if you don't do that, it turns into multiplication. Now you factor by grouping. You pull out common factors. And here we have a common factor of 3x, and that leaves you 4x minus 3. And over here we pull out a common factor of 2, and that leaves us a 4x minus 3. And when you factor by grouping, you should have this common binomial factor in each of your 2 terms. And so now if you factor out that 4x minus 3 from each term, in the first term, you're just left with the 3x. In the second term, you're just left with the positive 2. And that's another way to factor it. See, that's the mechanical approach. The guess and check is usually a little bit faster for me, just because I'm used to it. If you have to go off to the side to factor like that, that's where you do it. You do it off to the side. At least you know how. You're not just sitting there like, I don't know how to do it. It takes a little bit of effort, mental discipline, right? Now, let's do something here. Let's turn this into an inequality. let's say I wanted to know where 12x squared minus x minus 6 was less than 0. Can I solve that algebraically? Say no. No. I still see people trying to solve quadratic inequalities algebraically. It doesn't work. By the way, if you were absent, you need to email me your extra practice worksheet that we did on Friday, because I need to grade it. But if you email it to me, I'll see it, okay? So just email me a PDF copy of it. All right, so once we factor it, 4x minus 3, 3x plus 2, that's still okay because it's intact. What you can't do is set each factor less than 0. Don't do that. Now, the reason you would want to factor it is so you can find the roots. If it's less than 0 and you want to write the roots underneath there, or the x-intercepts or the zeros, it all means the same thing, you need to say so. You should be able to look at this right here and tell me what the x value is that makes it 0. Bring the 3 across, it becomes positive. Divide by 4, you get 3/4. The next one, bring the 2 across, it becomes negative. Bring the 3 under, and it's 3. So without physically setting them both equal to 0, you should be able to do that linear algebra in your head, right? But if not, you go off to the side and do it. Here's where you would go off to the side and do it. You would set this equal to 0. Now that it's an equation, you can set both of them equal to 0. You can't do that with an inequality, but you certainly can with an equation. Okay, so however you want to do it. Once you have those 2 roots, remember, our plan is to sketch a graph. There's negative 2/3. Here's 3/4. The parabola opens what? Up or down? Up. So we sketch just this little graph. And now we look at the inequality. When we set it up for domains, we always want it to be greater than or equal to 0. But we can have different inequalities. We want to know where this one is strictly negative. It's strictly negative when it's below. So is that going to be outside of or between? In between. Open circle, because it's strictly less than, open circle. So the solution to this is going to be negative 2/3 less than x less than 3/4. Or x epsilon negative 2/3 to 3/4. That's how you solve a quadratic inequality. But you got to be able to factor it. Okay, you don't solve it algebraically. All right, questions on factoring or this warm-up? It's good stuff. Every warm-up is an opportunity to reteach again. So really no excuses for you not being able to do something. If you need more practice doing this stuff, come see me, right? We'll sit at the table. I'll give you problem after problem after problem. Most of them math, right? Yeah. Okay, well, let's get back to the notes. Notes. Give us the notes. We love the notes. We were on A last time, right? And we found the domain. Yeah, we said x can equals 2. And so I told you that for sure, x equals 2 is a discontinuity. I'm going to move it over here. It is a discontinuity because it interrupts the flow of the graph. The graph lives immediately to the left and to the right of 2, but not at 2. Now, if we can't go to 2, essentially, because it's not in the domain, guess what human nature is like? If you say you can't do something or you can't go somewhere, we want to know why. We actually want to go there, right? Don't go to Area 51. You'll get shot. Oh, let's go to Area 51, right? I want to see the aliens. What's going on at x equals 2? I told y'all yesterday that it's going to be one of 2 things, right? It's either going to be a hole, or a vertical asymptote, a hole or a VA. What's the real name of a hole? Removable point discontinuity. Swiper, no swiping, right? And a VA or a vertical asymptote's real name is non-removable infinite discontinuity. Very good. Brady told us he thought it was a hole, and he gave some explanation that I didn't understand. Yeah, I don't even know if Brady understood it. But I'm going to teach everybody a way that everybody will understand. Okay, there's 2 ways to determine if the discontinuity is a hole or a VA. The first way I'm going to show you is by factoring. The factor in the bottom is x minus 2. I'm going to group it together in parentheses. The top, does it factor? It's one of those ones with the leading coefficient that's not 1. Well, let's see. Guess and check. 2 is a prime number, so it's got to be a 2x and a 1x. And then this 2 is also a prime number, so it's going to be a 2, 1 combo, and it's got to be a negative. They're both going to be negative. When your middle term is negative and your constant is positive, they both have to be negative. So that gives you a negative 4 on the outside and a negative 1 on the inside, which is a negative 5. What do you notice about the x minus 2 factors on the top and bottom? They're both there, right? So what happens? They divide out. Dividing out is the proper name, but we can also say that, hey, we removed the x minus 2 factor. If you can remove a factor that causes a 0 in the bottom by dividing it out, guess what type of discontinuity it's going to be? Removable. Yeah, there's that association of words. A removable point discontinuity is going to be a removable factor. If you can remove the factor that causes 0 in the bottom, then the root of that factor, in this case 2, is going to be a removable point discontinuity, also known as a hole. All right? So what that leaves us with then is that f of x looks exactly like the graph of 2x minus 1. We know what the graph of 2x minus 1 looks like, right? From algebra 1. That's the form mx plus b. That's a line, yeah? With a y-intercept of -1 and a slope of 2, up 2 over 1. The only thing is, it doesn't exist at x equals 2. There's a what there? A hole. Swiper swiped it. Yeah, Swiper swiped it. Now, I'm going to quickly show you the other way to determine if it's a hole or not, okay? Because there's an x minus 2 factor in the top and the bottom, if you were to plug a 2 in to f of x, in the top you're going to get 2 times, if you look at the factored version, 2 times 2 is 4, 4 minus 1 is 3. You're going to get 3 times 2 minus 2 is 0. What's 3 times 0? 0. You're going to get a 0 in the top, and of course you're going to get a 0 in the bottom. Because that factor is in the top and the bottom, when you plug a 2 in to the original function, you're going to get a 0 in the top and a 0 in the bottom. So here's what we could say. F of 2 equals 0 over 0. And you could try it in right here in the original. Let's try it. Let's try it on the original instead of the factored version. I know I'm going to get a 0 in the bottom, but in the top, what do we get? 2 squared is 4. 4 times 2 is 8. Minus 5 times 2 is 10. Plus 2. And that gives us what? -2 plus 2. Yep, we get 0 over 0. That's right. That's plugging it into the non-factored version. So if you don't want to factor to see if it removes, you just want to plug it in right away to the original version. If you get 0 over 0, guess what 0 over 0 means? 0 over 0 means, oh. I like to spell a hole like that with 2 O's kind of going down. Like you fell in a hole. 2 O's. 0 over 0 means hole. 99 times out of 99 and a half, 0 over 0 means hole. There's one time that we'll learn where it's a jump. For a rational function, a polynomial over polynomial, if you get 0 over 0 when you plug in, it's a hole. Okay, it's a hole. If you can factor and remove it, it's a hole. So those are the 2 ways to determine if a value that's not in the domain because it causes 0 in the bottom, and therefore is a discontinuity, is a hole. What are the 2 ways? Factor and remove it, divide it out, or plug it in and get what? 0 over 0. Those are the 2 ways. Factor and remove it, or plug it in and get 0 over 0. That's how we know it's a hole. Now, let's see if we can sketch this dude. Since we know what 2x minus 1 looks like, let's review algebra 1. Algebra 1. Here's -1, and then the slope is up 2, so there's 1, 2, right 1. So we're at the point 1, 1. Let's do it again. Up 2, that puts us up here at 3, right 1, that puts us at 2. So if we connect these dots,
But wait,
hang on. But wait, now that I have the graph, but wait, what's wrong, Brady?
it can't go over 2.
Right, we can't pave right over 2. So get your little eraser tool or your white and just kind of white it out there. And of course, we accentuate it by putting an open circle there. Now, what point used to live there before Swiper swiped it? What was the coordinate that used to live there? 2,3, right? How could we figure out the y value if we didn't just happen to stumble on it when we went up 2 over 1, up 2 over 1? When x equals 2, we can plug it into the equation of the line, right? We get 2 times 2 minus 1, which is 4 minus 1, which is 3. Because we know what the function was, 2x minus 1, before Swiper swiped the hole, we can actually find the y value of the hole. We can find the coordinate x comma y of the missing point. All you have to do to find the y coordinate of the missing point is factor, divide out, and you'll get the original function that used to live there, and then plug the 2 into what's left. That makes sense, right? Because this is what it was before. Now notice what I did over there. I said when x equals 2, I plugged it in. Is that the same as f of 2? Could I just put f of 2 there? I wanted to show that I was plugging it into 2x minus 1. But could I just call this f of 2 right here? I can't call it f of 2 because does f of 2 exist? No, it's a hole. It's not in the domain. So you got to be careful there. When you're plugging in, you can't use function notation because f of 2 is undefined. But we know what the other function used to be. That's why we say 2x minus 1, x can equal 2. If you want to go ahead and say, you know, let g of x equal 2x minus 1, the original function, the OF, if you will, the OG of functions. Now you could say g of 2, okay, which is not bad. It's not a bad idea to do that. But don't make the mistake of saying f of, because remember, f of doesn't exist. Will I have you find the y value of the hole? Absolutely. How do we find the y value of the hole again? We factor, divide out, and just plug that missing value of x that's not in the domain, just plug it back into what's left, right? Because that's what the function used to be. And there used to be a y value there before Swiper came in and swiped it, okay? So what we can say here then is not only is it a discontinuity, but we could say f, or f of x, has a hole at the coordinate 2, 3. And now, if we track down Swiper and we can get our point back, we know exactly the GPS coordinates, if you will, to put that point back down, to cover that pothole up, to put the manhole cover back on. We'll go to the point 2, 3 and set it down, okay? So there's what the graph looks like. Pretty neato mosquito. Does your calculator know that? Does your calculator show the hole if you were to graph it? I don't know. Let's see. Some of y'all have fancy calculators that are color, and I have some up there that are color. And, you know, these things are improving in their programmability all the time, but let's do it together. I don't know if there's a need to jump up and grab a calculator, but everyone can do it at their desk easily. There we go. Let me load this guy up. And let's type them in. Let's graph it. If you want to jump up and grab one, you can. Y equals, to get the horizontal division bar, you remember how to do that? Alpha y equals. Alpha y equals. That activates the F1, green F1, and there's N over D. All right, so then 2x squared minus 5x plus 2, cursor down, x minus 2. Click to the right, make sure it looks exactly like what you have on your paper, And now zoom 6 is a good place to start. That's your standard negative 10 to 10 window. Is that what I was expecting? Nope. That means that we either did the problem wrong or I typed it in wrong. Let's see.
Wait, there's no minus sign.
Ah, very good. I didn't put a minus sign in there. 2x squared. I just went right to 5x. So that's multiplying. That's actually giving me 10x cubed. That's why it looked like a different type of function. So yeah, troubleshoot your own work. So to insert, you hit second delete. And there's the minus right there. Or you can just type it all in again. Now I can click to the right. I didn't catch that because it's so small here. Now that looks good, right? So now I'll hit zoom 6 again. And that should look like a line. Oh, yeah, yeah. Hey, do y'all see the hole at 2? No, I don't either. But watch, if we hit the trace button and we type in a 2, look what it says the Y value is. It's blank, right? It's blank. But if you click to the left and right, now that you're in trace mode, now a value appears on either side if you click to the left and right, but not at 2. Now let's do this. Let's zoom in near 2. With the cursor there, if I hit zoom in number 2, I just want to see if it'll eventually show it. And now I have to kind of make sure that I'm near the graph, near 2 still. So somewhere in there, I want to zoom in again. So I hit enter. I'm zooming in. We're going in for a closer look, right? How thick is a point? Infinitely thin, right? So every time I'm recalibrating, trying to get closer and closer to 2. Oh, do y'all see a gap yet? I don't either. How long can we do this? Indefinitely, right. Come on, show the hole, baby. The hole's there. You know the hole's there, calculator. Show me the hole.
Well, it's indefinitely small.
Right, right. Now let's see if it's even still there. Look at it, I'm zooming trace. Let's type in a 2. Ah, it still says it's not there. Now if I click to the left, okay, let's zoom in again. I want to see a gap. I don't think the calculator is going to show me a gap, do y'all? No. Sometimes it will show a gap. It depends on the pixel resolution. But don't expect to see, I'm zoomed in so close here. Don't expect to see a gap in the graph. It looks like a line. But we know that it's there, right? So when we draw it on our paper again, we don't draw it to scale. We put a big open circle right there at 2, comma. And how did we find the 3 again? How do we know the Y value of the hole? Yeah, because of 2x minus 1. It's what's left after we divide out the whole factor, and then we can plug it into what's left. Don't call it f of 2, but you can say when x equals 2, or rename it g of x and then do g of 2, okay? Because that's the function that used to live there before Swiper swiped. P3 him. P3 Swiper. He deserves it. Comments or questions? We'll be ready for a quiz tomorrow, almost. Let's keep going. Cool. Letter G, or letter B, function G. I'm going to pause this.
I found it correct, but I feel like it's wrong.
Well, if you look at it, what's the domain? You can spot it right away. Let's not even mess around. Let's not even say x minus 2, the denominator can't be 0. Looking at the denominator, you know x can't be what? 2. Let's just go ahead and state the domain. I'm going to state it up here. D sub G is the set of all x such that x ain't 2. Interval notation, of course, negative infinity to 2, step over 2, go to infinity. So it has the same domain as the previous guy. But is this a discontinuity at 2? Yeah, G has a discontinuity for sure at x equals 2. It's going to be either a whole or a vertical asymptote. It's going to be either a whole or a vertical asymptote again. Let's go ahead and see. Let's try the plug-in version this time first, okay? Let's plug in colon g of 2. I know I'm going to get a 0 in the denominator, right? I know that. But if I get a 0 in the top, then I know it's another whole. Yeah? What do I get when I plug a 2 into the top? 2 squared is 4. 4 times 2 is 8. Plus 2 times 3 is 6. Minus 2. That gives me 14 minus 2 over 0. That gives me 12 over 0. Uh-oh. 12 over 0. Is 12 equal to 0? No. I didn't get 0 over 0, did I? Now, here's the deal. If you don't get a 0 in the top, x minus 2 is not a factor in the top. Because the only way you would get a 0 in the top when you plug in a 2 is if x minus 2 were a factor. And therefore, if you don't get a 0 in the top, x minus 2 is not a factor of the top. So, just thinking, if it's not a factor in the top, will we be able to divide it out? It has to be in the top and the bottom to divide it out. No. So, if we can't divide it out, we can't remove it. And therefore, it's non-removable. Guess what type of discontinuity this is going to be? The vertical asymptote, which is the non-removable infinite discontinuity. Yeah. It turns out that if you plug in, I'm just going to say, if you plug in and you get non-zero over 0, non-zero 0 means that there's a vertical asymptote there. 0 over 0 means there's a hole. Okay? But any non-zero number over 0 means there's a vertical asymptote. That's pretty cool. Now, let me tell you this as well. Non-zero over 0 is actually equal to some type of infinity, believe it or not. The reason you can't divide by 0 is because it's some type of infinity if it's non-zero over 0. If it's 0 over 0, that's a different breed. Okay, but non-zero over 0 is some type of infinity. In fact, the reciprocal of 0 is infinity, and the reciprocal of infinity is 0. The reciprocal of 0 is infinity, and the reciprocal of infinity is 0. What's the reciprocal of infinity? 0. What's the reciprocal of 0? Infinity. Watch, I'll show you. Let's come up with a 0. 0 could be not just 0, but how about 0 over 5? Is that equal to 0? 0 has all different types of forms, right? 0 over 5, 0 over 10. Now, let's flip it. Let's reciprocate it. You get 5 over 0. Guess what 5 over 0 is? 0. No. 5 over 0 is some type of infinity. And that's why there's a vertical asymptote there. Because remember, the vertical asymptote is called a non-removable infinite discontinuity. It forces the y values to go up towards infinity or negative infinity. So the reciprocal of 0 is some type of infinity, plus or minus. And what's the reciprocal of infinity? 0. And the reciprocal of 0 is some type of infinity. That's why non-zero over 0 is a vertical asymptote, because the vertical asymptote forces the y values to either infinity or negative infinity. I'm inculcating it into you. That was yesterday's word. Is what we're learning considered grammary? Is this witchcraft or the occult that we're learning? Is math kind of like voodoo? Oh, some people might think so. Right? All right, now, can we factor the top? Let's see. I think we might be able to factor the top. 2x something, x something. I've got to get a 3. I've got to get a 3 in there, so maybe a 2 and a 1 again for that. But now, let's see. I got to make this a positive 4 and a negative 1. 4 minus 1. There it is. So notice it does factor. The top's not always going to factor. But in this case, it does factor. And does x plus 2 divide out with x minus 2? No. So in this case, we could say that this is non-removable. non-removable factor. And a non-removable factor means that it's going to be, let me use the other color here. A non-removable factor means it's going to be a non-removable discontinuity. So there is the association there. Now, because the top won't always factor, if you're trying to determine if it's a hole or a VA by factoring the top, if it ends up being a vertical asymptote, it may not factor. It doesn't have to factor. So what I would always recommend is try the plug-in method first. Try plugging in first, okay? If you get 0 over 0, you know it's a hole. Then proceed to factor, okay? But if you get non-zero over 0, it's a vertical asymptote. It may or may not factor, okay? And when I say factor, I mean factor everything. The bottom doesn't have to necessarily be factored completely or just have a single factor in it. All right, so that's going to be your first thing that you do. Never not first. Once you find the domain, try direct substitution. Plug in that taboo value that gives you a 0 in the bottom. You know it's going to give you a 0 in the bottom, but what it gives you in the top is going to be revealing. If you get a 0 in the top as well, boom, it's a hole. 0 over 0 means hole, right? Factor the top. It's going to have the same factor, so that can help you factor. If you already know what that is, factor it. If you get non-0 over 0, you know it's a vertical asymptote. It may or may not factor. Now here's another important theorem that we're going to be using, okay? And I've been talking about it, but I want to state it, okay? It says x equals a is a root, which is also known as a 0, right? Which is also known as an x-intercept of f of x, if and only if, which could be written as IFF or a double-headed arrow, x minus a is a factor of f of x. This is called the factor theorem. It's an if and only if, which means it works both ways. If you know a root, you know a factor. If you know a factor, you know a root. We've been using it from the bottom to the top already. Like if you factor something and you get it like as x minus a equals 0, like let's say that was x minus 3 equals 0. You know the root is what? 3, right? Or if it was x plus 5 equals 0, what would be the root? Minus 5, negative 5, right? So we've already been using it one way, but it also works the other way. If you already know a root because you've plugged in and gotten a 0, let's say you plug in a 3 and you get a 0, then x minus 3 is going to be a factor for sure. If you plug in a negative 5 and get a 0, then x plus 5 is going to be a factor. So that's helpful when you get 0 over 0. If you plug in and negative 5 and get 0 over 0, you know the bottom and the top have to be x plus 5 times something, right? If you know a root, you know a factor. And if you know a factor, you know a root. And if you know a root, you know a factor. But if you know a factor, you also know a root, which means you also know a factor, which means then you know a root, which of course then I know what the factor is if I know the root. And of course, if I have the root, I have the factor, right? It's like a package deal. They come together, right? You can't have one without the other, like love and marriage, love and marriage. They go together like a horse and carriage. They go together like a root and a factor. That doesn't rhyme, but oh well. All right, how are we doing on time? 5 minutes? All right. You've seen an example of one of each of them, right? I don't even know where I'm at. Where am I at in the notes?
You're on the page. You're on C of example.
Oh, there, I'm hiding it. Okay. Let's see if we can get this one factored right away. This one's Texas of x, okay? Let's find the domain, okay? We know that x squared minus 4 shall not, cannot be 0. That means x minus 2, x plus 2 shall not equal 0. Now, here's where we use the factor theorem. If we know a factor, we know a root, don't we? We don't have to set x minus 2 equal to 0 and solve algebraically. We don't have to set x plus 2 equal to 0 and solve algebraically. If we know the factor, we know the root. The root of x minus 2 factor is 2. What's the root of the x plus 2 factor? Negative 2. If you know a factor, you know a root. These are the two values that are not in the domain. So the domain of t is the set of all x such that x is not equal to plus or minus 2. Those are going to be discontinuities, yes? They're not in the domain, but the graph lives to the left and right. Now, the question is, are they holes or VAs? Let's see. Let's come off to the side here. Let's try t of 2. If I plug a 2 into the top, I get 2 squared is 4. Minus 2 times 4 is 8, minus 12. All over 0. That gives me negative 4 minus 12 over 0. That's negative 16 over 0. Ah, so guess what this function has at 2? A VA. Good. We have a vertical asymptote at x equals 2. It's a vertical line. I'm bleeding. Huh? All right. Hang on. We're not caught up with you yet. Yeah. Let's try t of negative 2. If I plug negative 2 into the top, I'm getting negative 2 squared, which is 4. Negative 4 times negative 2 is positive 8. And then minus 12 all over 0. That's 12 minus 12. That's 0 over 0. So guess what we have at negative 2? A hole at x equals negative 2. But wait. We can do better than just saying a hole at negative 2, can't we? If it's a hole, it's a point discontinuity. Yeah? And if it's a point, it had originally not just an x value, but also a y value. How are we going to find that y value? Factor, divide out, and plug into what's left. Now, because negative 2 caused a 0 in the top, it's a root. Guess what the corresponding factor then is? Come on, people. If negative 2 is a root, then x minus negative 2 is a factor, which is what? X plus 2. We know that. If we plug in and get a 0, then x minus that number is a factor. So if negative 2 is the root, x plus 2 is the factor. We're going to be able to factor the top as x plus 2 times something, and the bottom as x plus 2 times something. But we're going to have to wait to do that when? Mañana, el sol. I don't know how to say it comes out in the morning. I'm trying to sing the Annie song in Spanish, but I'm not fluent enough. Yeah, I'm okay. I just picked the scab. Don't come near me, though. Bloodborne pathogens. Yeah. I mean, I'm fine. I mean, my blood is fine. I'm not infected with anything. But, yeah, I'm good. Were you asking about this, Aiden, or were you asking about mentally? No, the blood. Oh, okay. I was mentally, no, I'm not okay, Aiden. But, yeah. Yeah. But yeah, I'm good with this. So we'll have to finish this up tomorrow. Y'all have a great rest of your day. And I'll see you then. Quiz tomorrow on whole or VA, okay? Be ready.